Hello! Welcome to part 2 on our video series on caching with Redis. Today's topic, caching slow database queries. It's not as hard as it sounds, and there's a big performance payoff when you get it right. We'll be using a weather app in our example, so bring an umbrella. It's gonna be raining knowledge. Today we're going to cover the look-aside caching pattern. With look-aside caching, we first check the cache for the data we need before querying the database directly. In other words, we look to the side in our cache before we look in the database, hence the name. To implement look-aside caching, we need to write the application logic that gets and sets data in the cache. We need to set a time to live, or TTL, for the cached data. And we need to make sure that our Redis database is using the right eviction policy. I'm going to show you how to do all three of these things, but first we need to decide which slow database query we're going to cache. Let's take a quick look at our example application to see what we can find. Our example application, called Ready Weather, gives daily weather updates based on your location. The app also provides historical weather readings dating back to 2010. The app's backend retrieves daily temperatures, wind activity, and weather conditions reported from weather stations and stores them as individual rows in a SQL database. One of the app's features is to display average temperatures. Let's find the average daily temperature for the last 6 months in Iceland. Here's the SQL query to compute this average. And here's the Node.js code that runs this query. This SQL aggregation query is simple enough, but requires the database to iterate over 6 months of daily reports from numerous weather stations. That means that we're traversing over 100,000 rows. On my local machine, it takes a little over 1.7 seconds to run this query. Ooh, that's cold. This query is a perfect candidate for caching. There's never a need to calculate this temperature average more than once per day, as the result won't change. So, to give our users the fastest possible response time for this query, we'll store the average in our cache after the initial calculation. Now, whenever a request for this calculation comes up, we'll simply return the cached value. So let's look at the actual caching logic in the Node.js backend. First, the application needs to be able to read from the cache. To read from the cache, we need to know the name of the key where the cached data is stored. We cache these queries based on the location, the start date, and the end date. So we need to construct a key having these fields. Once we have the key name, we issue a GET request against Redis. If the key exists, we immediately return its value. That's a cache hit. If we don't have an entry in the cache, we'll incur a cache miss. So we'll run a query against our SQL database. We'll return the result to the user, storing it in our cache using an appropriately named key. This ensures that future requests are served with data from the cache. This application uses SQLite, and its driver returns results as a JavaScript object. So we'll need to serialize this object as a JSON string before storing it in Redis. To keep the data in our cache accurate and relevant, we'll also want to set TTLs on our cache entries. A TTL, or time to live, determines how long the entry stays in the cache. Here I'm using the set commands EX option to ensure that this cache entry will expire in 24 hours. Why are we using TTLs in our weather app? The average temperature from 6 months ago up to today won't reflect a 6-month average calculated tomorrow or the next day. Since we receive new data every 24 hours, we'll want to clear the day-old entries from our cache. We've now set up caching to prevent repeatedly running slow database queries and to dramatically speed up response times. Next, we need to think a bit about our cache itself. Specifically, what happens when our cache runs out of memory? This is where eviction policies come into play. The eviction policy determines how Redis behaves as it nears maximum capacity. If we don't set up an eviction policy, then Redis will reject all writes when it runs out of memory. When caching, it's best to let Redis evict data when memory is running low. The eviction policy we choose determines how Redis will go about evicting data. One of the most common policies is LRU, or least recently used. The volatile LRU policy selects the least recently accessed, or used, key that has a TTL set. This is a fantastic default policy for caching apps, and it's the one we'll use here. To set an eviction policy on your Redis instance, comment out the max memory policy line in the Redis configuration file and replace the word no eviction with volatile-LRU. Restart your Redis server, and you're now using the new policy. So let's reflect on how introducing caching has improved our app's performance. The result of a SQL query that took 1.7 seconds to complete is now cached, resulting in an average response time of 2 milliseconds. Setting a 24-hour TTL on our cache keys helps us strike a balance between keeping the keys fresh and minimizing the load on our SQL database. We also added a global eviction policy, so if the cache gets low on available memory, Redis will automatically remove the least recently used entries. And that's clever. Thanks for watching. Keep your eyes to the sky and your feet dry. I'll see you again soon.